Hello everyone, this is lesson 2.2 Flex Control. In this lesson, I'll teach you how to use a flex control sensor to change the position of a servo motor. I'll also be going over different motor applications and how pulse width modulation works. So this is a servo motor. A servo motor is different from a regular motor because a servo motor is able to withstand large amounts of torque. When a regular motor is just made for simple applications such as wheels on a car or rotating or a propeller on a fan or a quadcopter. These, however, are used to move large objects or even control a whole arm. So an application for a servo motor would be something like this. So this is basically a robot arm. So I can see I have 3 servos on here. This is a large servo that can carry the most amount of torque. And then I have another medium servo just right here. And then I have a smaller servo at the pinchers over here. So as you can see, I use 3 different servo motors to control all the different joints of an arm. This is just one of many applications you can use with just these tiny servo motors. Okay, so I have my servo motor over here, my flex sensor over here, and my circuit right here. So what my flex sensor basically does, it provides values between 0 and 1023, depending on how much I flex it. So if there's no flex at all, I won't get any resistance, thus I would get 0, right? If it's fully flexed, let me try to flex this for you. So if it's fully flexed or fully bent, then you're going to get 1023. So 0, and then it's going to go 100, 200, 300, and then so on to 1023, or 1024, sorry. So with that in mind, I'm going to use those values to control the position of the servo. So in my circuit diagram, I have a 10K resistor, and then I'm going to plug in the flex sensor. So, and it's also plugged into analog pin 0. So once I plug this in, you can see the servo has moved to a position. So the flex sensor is currently relaxed right now, so no resistance is provided to the circuit, and thus no value is given to the servo motor. So as you can see, if I flex it, it starts to turn. Sorry, let me try this again. Flex it, starts to turn. More and more I flex it. The flex sensor is really flimsy, so it makes the servo really, really jittery. Right? But you get the general principle. So if you can see here, if I apply a certain force to the servo motor, you can actually feel it pushing against you. This is something called pulse width modulation. So there's a voltage that is provided to the servo motor, and then a certain pulse is sent out every 20 milliseconds or so to fight against my force that I'm applying right here. So that is measured by torque. So torque is basically force times distance, right? So the amount of force I'm applying equals the amount of torque in the servo. So small servos that the small servos that come with this kit, the SparkFun kit, I think they have a torque value of 5 to 6. And when these servos, this is a high power servo, so it can hold up to a bit more torque or force. So for pulse width modulation, 1 millisecond pulse moves the servo motor to 0 degrees and holds it in place. The max pulse is around 2 milliseconds, which moves the servo's position to its max position, which is 180 degrees. And again, it would stay in that position till you apply a big enough force. I don't know if I can do it. The servo is really strong. I can't forcefully do it. If you try to forcefully turn it, then you can risk stripping the gears inside the motor and thus damaging the whole thing. And again, this is what makes servo motors so special from normal DC motors. Okay, I'll show you how to circuit this in a fritzing diagram And then we can also move on to the code and software portion of this tutorial. Okay, after we launch our Arduino sketch, now let's start coding. So first of all, we're going to include the Servomotor library. So the Servomotor library is just include servo.h. Okay, and then we're going to initialize our Servomotor. Just type in servo and then my servo. So after we have initialized, we're also going to locate the pin for our flex sensor. So write constant integer flex underscore pin equals A0. So that just end log pin 0. So now we gotta initialize some of our variables. So we're gonna need a variable to read our flex sensor values and a variable to read our servo position. So we could go int flex pose equals 0, int servo pose equals 0. Okay. So now that we have those initialized, let's go into our setup. We're gonna begin our serial monitor. And then we're going to initialize the servo and attach it to a servo pin. Oops, sorry, I forgot to initialize our servo pin. So let's go back up here, constant int servo underscore pin equals, and we have to attach it to pin 9. On the Arduino, there's a few digital pins that have a tilde symbol on it. The tilde symbol looks like this, the little squiggly line, right? So the little squiggly line means that this digital pin can also act as an analog pin by using pulse width modulation, and pulse width modulation is what we want. So my servo.attach servo underscore pin. So this means we're attaching a servo to pin 9, basically. Okay, and that's all we need to write up in the setup. This code is very, very simple. Okay, so let's go into loop flex pose equals analog read. Remember, because we're reading the analog values from the flex pin, or from the flex sensor, sorry. Analog read flex pin. So this means we're going to read analog values from pin analog 0. So this is our analog value. Now we're going to try to map it out to our servo motor. So this will give us values between 0 to 1024. We want to map it out to values between 0 to 180 for our servo motor. So for that, we're just going to type in servo pose equals map flex pose, and then we are not going to use the exact min and max to show better results. I'm going to pick a smaller range so that I can see bigger results on the servo motor. So I'm picking values between 600 and 900 on the flex sensor. So that means I won't have to bend it all the way in order to see the full effect. And then this will map it out to 0 and 180 degrees on the servo, sorry. So with that, I'm also going to constrain, oops, I spelled map wrong. I'm also going to constrain the values. So this just means that the servo position will not go under or over 0 or 180 degrees. Okay, because let's say if our flex pin accidentally gets like 910 or something, which it will, we would get a bigger number than 180. So we're just going to constrain it just in case. Okay. After that, we haven't actually moved the servo yet. So as we declared our servo motor up here, we're going to write my servo dot right servo position, servo pose. So that basically means we're going to write the angular position to the servo. Okay. So with this, we're also going to print out all the data to the serial monitor. We're going to go serial.print. I'm going to print everything on the serial plotter so that I can see the graph going up and down. Serial.print, that is space, and serial.print 180. So this means I'm going to constantly print 0 and 180 on the graph, so I know those are my max and mins. Sorry, I forgot a comma over here. I had it before as a bracket. I should have been a comma. Okay, so continuing on back over here. So serial.print, I'm adding the spaces in between each of them. Serial.print, flex pose. Actually, no, I'm just going to print. I'm sorry, I forgot to write a comma over here. It was a bracket before. It should be a comma, sorry about that. So there should be a comma right there. And then now, lastly, we're going to print the servo position. So this will basically show us what it looks like on a graph. Delay 50. We're just adding the delay just so that it won't be super fast, so we won't be able to read it. Delays always clean things up by slowing it down and stuff. Okay, yeah, this is pretty much the program. It's fairly simple, but the output and the results look really cool because you actually get to see a mechanical motor moving rather than like an LED blinking or a sensor reading values and giving you new numbers. Alright, so now that our code is ready, we're going to upload it. So remember, when we're uploading the code, we got to go to Tools, Board, select our board. In this case, it's Arduino Uno, and then we select our port. I know it's not my iPhone, my Bluetooth, or this is also another Bluetooth, so it has to be my USB serial device right here. So after I selected that, I'm going to go ahead and press upload. So now that's uploading, it should be written to my board. Okay, so now let's go to our board. So here's our board. As you can see, I bend the sensor and the servo turns. So now we're going to run the serial plotter. So here's the serial plotter. Make that a bit bigger. And you can see it's staying still at, what is that, like 90 degrees or something, right? That's its still state. Okay, and then now, as you can see, as we bend it, I'm going to start to bend it. See it go up and down. Yeah, you can see there's a bit of error sometimes because this thing is really flimsy, and whenever you're dealing with physical hardware, not everything is going to be 100% right off the bat. You see it's turning, but you can see it's never going above or below 0 or 180. If you can see, the orange line represents 180 and the blue line represents 0. So right now it's still, I'm not touching it right now, it's just staying in place. In the next lesson, we're going to go over how filters work and why we use them and how useful they can be in the future or for any other applications you decide to create. So thank you for listening and have a good day.